Welcome back to our series on AI and machine learning. In this lesson, we'll explore the fascinating field of reinforcement learning. This type of learning is all about agents interacting with an environment to achieve long-term goals. We'll cover key concepts, real-world applications, and a popular algorithm called Q-learning. Let's start with the definition of reinforcement learning, or RL. Reinforcement learning is a type of machine learning where an agent learns to make decisions by performing actions in an environment to maximize some notion of cumulative reward. Unlike supervised learning, where the model learns from labeled data, RL learns from the consequences of its actions, using feedback from the environment in the form of rewards or penalties. To understand RL, we need to grasp several key concepts: agents, states, actions, rewards, and policies. The agent is the learner or decision maker, like a robot or a software program. The state represents the current situation of the environment, as perceived by the agent. Actions are the choices the agent can make to interact with the environment. Rewards are the feedback signals given to the agent after it takes an action, indicating the immediate benefit of that action. Policies are the strategies or rules the agent follows to decide which action to take in each state to maximize the cumulative reward over time. Now let's discuss some real-world applications of reinforcement learning. RL is widely used in game playing, autonomous driving, and robotics. In game playing, RL algorithms have achieved superhuman performance in games like chess, Go, and video games. For instance, AlphaGo, developed by DeepMind, used RL to defeat the world champion in the game of Go. In autonomous driving, RL helps vehicles learn to navigate complex environments, make decisions in real time, and optimize routes. In robotics, RL enables robots to learn tasks through trial and error, such as picking up objects, walking, or even playing sports. One of the most popular algorithms in reinforcement learning is Q-learning. Q-learning is a model-free algorithm, meaning it doesn't require a model of the environment. Instead, it learns the value of actions and states to maximize the expected reward. The Q in Q-learning stands for the quality of an action, which is the expected utility of taking that action in a given state, following the optimal policy. Here's how Q-learning works. The agent maintains a Q table, which is a matrix where each row represents a state and each column represents an action. Initially, the Q values are set arbitrarily. The agent then interacts with the environment and updates the Q values based on the rewards received. The update rule is based on the Bellman equation, which considers the immediate reward and the maximum future reward achievable from the next state. Let's break it down with a simple example. Imagine a robot in a grid world where it needs to find the shortest path to a goal. Each cell in the grid represents a state, and the robot can move in different directions, representing actions. The robot receives a positive reward when it reaches the goal and negative rewards if it hits obstacles. By exploring the grid and updating the Q values, the robot learns the optimal path to the goal. To summarize, reinforcement learning is a powerful type of machine learning where agents learn to make decisions by interacting with an environment to achieve long-term goals. Key concepts include agents, states, actions, rewards, and policies. RL has impressive applications in game playing, autonomous driving, and robotics. Q-learning is a widely used algorithm where agents learn the value of actions and states to maximize rewards. In conclusion, reinforcement learning opens up exciting possibilities for creating intelligent systems that can learn and adapt through experience. Understanding these concepts and algorithms is crucial for anyone interested in developing advanced AI systems. In our next lesson, we'll dive into deep learning and explore how neural networks can be used for more complex tasks. Stay tuned.